So, example 5. We have 4 moles of an ideal gas. They are compressed, this time isothermally, from 100 liters to 20 liters by a constant pressure of 7 atmospheres. Find QW, delta U, and delta H. Okay, pretty straightforward. Again, we have a pretty good take on it by now. We've done a couple of problems just like this. And again, we're just going to keep doing a lot of problems that are sort of the same just to get a sense of it, just to become comfortable with it. That's what we want. Well, let's go ahead and do work first. Work is equal to the external pressure times the change in volume. They give us the change in volume. That's just the, 100 to 20. It's final minus initial, so it's 20 minus 100, so it's actually minus 80. So the external pressure is 7 atmospheres and minus 80 liters. So we end up with minus 560 liter atmospheres. Okay, well, minus 560, let's go ahead and convert this to joules. Minus 560 liter atmosphere times 8.314 joules times divided by 0.08206 liter atmosphere. That cancels. You end up with, I'm going to go ahead and express this in kilojoules, minus 56.7 kilojoules. Well, it's an isothermal process. So we already know that an isothermal process, delta U equals 0. And if delta U equals 0, that means 0 equals Q minus W, which means that Q equals W. So Q equals minus 56.7 kilojoules. So that takes care of Q. And we have already worked out the delta H part. Delta H is equal to delta U plus delta PV. We are dealing with an ideal gas. This is 0. This is 0. So our delta H is 0. And again, in this particular case, what's happening is this. Here is the system. Here is the surroundings. And notice in this case that the work and the heat are negative. Work is negative 550. Sorry, here I am talking, I'm not writing properly. Minus 56.7. No, this is right. I have it in the next line. Ah! Minus 560, minus 56.7 kilojoules. Everything is good. The work done is actually negative. That means work is destroyed. That means work is leaving the surroundings. 56.7 kilojoules is moving from the surroundings to the system as work. Heat, minus 56.7 kilojoules. Heat is negative when it's leaving the system. This is a compression. The surroundings are doing work on the system. 56.7 kilojoules of work. 56.7 kilojoules of energy transfer as work from the surroundings to the system. This is an isothermal process, which means the temperature has to stay the same. If we put energy into the system, the temperature is going to want to rise, but we want to keep the temperature down. So we have to take energy away from the system in order to keep the temperature at the same level. So heat moves as energy, or energy moves as heat from the system to the surroundings. Therefore, you get a total of delta U equals 0. In other words, there's no energy change for the system. That's what's going on here. Okay, we'll go ahead and we'll stop it with these 5 example problems, but certainly there are more example problems to come, quite a few more. So thank you for joining us here at Educator.com. We'll see you next time. Bye.